Wait. Okay, just kidding.
Okay.
Wait. Okay.
Okay, welcome everyone to CyberWizard lecture on building a web app from zero. So in this lecture, we're going to cover how we can build up a lot of different kinds of functionality and combine them all into something that is sort of a whole web app. So where do we start? Well, I think the best way to start, what I do, is just do makedir, the name of a project, like web app. I've already done that. And do npm init as the first step. So when you do npm init, and I'll just delete my package.json right now. So you do npm init in a new project. It asks you a bunch of questions. You can just hold down the enter key if you don't feel like answering them. And now we have this file, package.json. Package.json has a bunch of stuff in it. If you've installed any packages, it puts them in the dependencies list, although I don't need any of those in this case. It sets up a little script stub, and we'll be talking more on that later. The cool thing is, once you have a package.json file, you can start installing some packages. So to start with, we're going to install a few packages. So once you've done makedir and npm init and held down the enter key, you can type npm install --save xstatic and routes. Those are the first packages we'll be using. So hit enter. npm will go ahead and download those and put them in this place called node modules. So if I look in node modules, there's going to be a lot of stuff in there, in my case, but see that node modules routes exist and node modules xstatic exists. So these are both packages that we can use. So when we require them in our program, routes and xstatic, they'll be available. So the first thing to notice is that when you do npm install, you get the packages locally in your project. So instead of node modules living in some kind of system directory, like user local whatever, or somewhere deep in your home directory, it's in this project directory. That's a really nice property if you have a bunch of different projects on the same system, because each project can have separate dependencies. So you don't have to worry about if you upgrade the version of a library, it's not going to break other things in your whole system. So I think this way of doing it is kind of nice. It takes some getting used to. The other thing is, because when we did npm install, we did --save. What that did is it automatically added those libraries to our package.json file. So here we have xstatic and routes. There we go, that's a little bit easier to read. Hang on a sec. Okay, so the next thing that we can do is start to build our server file. So if you just do vi server.js, here we go, empty file. So how you make a server in Node, we covered this a little bit, but there's a library built into core Node.js called HTTP. And you can do require HTTP like this, and then you can make a server by calling http.createServer. And that function takes a callback as an argument.
Is this one called web app, by the way?
What?
Webapp.markup? Notes?
Yeah, but those aren't complete yet, so just ignore that. So the notes will be available later online. So anyways, we call http.createServer. We pass it a function that as arguments, we get a request as the first argument and a response as the second. You can name those whatever you like, but the common names are rec and res. And so we'll get to what goes here in a moment inside of the function, but for now, we'll call server.listen. This is where you provide a port, so say 5,000 or 8,000, something easy to type and easy to remember is good. And now we can just do a little stub implementation, so we can say res.end beep boop. This is pretty much exactly what you get if you go to the Wikipedia page for Node.js. You see a server very similar to this. So once you type that all out, we can run it. So I'll just give you a few seconds to finish typing a bit. So you do res.end inside of callback. Boop. So you can run your server by typing node server.js like that.
Can you just do server.listen at the end? Server.listen and you give it a port?
Yeah. at the very end, you call server.listen with the port number. So once you do node server.js, you can now, in a browser, go to localhost :5000 or whatever port number you used. And here we see beep boop, which is the message that we got when we called res.end. So here's what the server looks like again. And this is also pretty much what you see on the Node.js website. So the next thing that we can do, I mean, that's pretty cool, right? We can type different messages. A few things to notice is we have a request and a response. So one thing that the request has is a rec.method and rec.url. So if you go ahead and console.log rec.method and rec.url, we can try some different things. So go ahead and add this to your server program, rec.method, rec.url, and we can see what those values are. They're both going to be strings, and the rec.method is the HTTP verb, like get or post or put, and the rec.url is the path. That's the part of the address bar that is after the host name.
And like rec is request.
Yeah, rec is the request.
Okay, that just throws me off when I just use. I know it's like super. I was just gonna say, is everybody caught up to this? Like, does everybody get where we're at right now?
Not quite.
Is that okay?
I don't know if we're going to be able to get through all this stuff if we go too
Yeah,
slow.
go ahead.
Okay, then just.
I think I'm just going to go fast. So if you get lost, that's okay, because the notes will be online later. So maybe we can just cover all of the different topics fast and not worry about everybody being caught up. Okay. So anyways, if we do rec console log rec method rec URL like this, rerun our program, if we go to the same URL in the browser, now on the console we see these two messages, get slash, and this one's kind of silly, get slash favicon.ico. This is the icon that the browser puts on certain, like if you go to twitter.com, you see this little icon in the top right once it finishes loading, but it's going to take forever because Twitter is really slow. There we go. So that's the favicon. Oh, sorry, you can't see that. There it is. It's a little Twitter bird. So we don't have to care about that necessarily, but what we do need to do is figure out what kind of content we want to put. So that's a get. We can talk more about forms later, but for now, I think a good next thing to do is we can make a public directory. So this is where we're going to put our static assets. Sometimes you'll see this called static, sometimes public. It doesn't really matter because it's whatever name you want it to be. So I like to call it public. So if you do make dir public, inside of the public directory, we can make some HTML. So we'll make a file index.html, and we can put doc type HTML, and then some HTML, maybe like a title, a head, title tag, slash head, and body with a message like h1 cool. Body slash HTML. Okay, so we can quickly write some HTML. Now if we want to serve up that HTML, I'll show you one way to do that first, and then I can show you a more general way. So one way that we could serve up that HTML is to use the FS module. So if we require FS, like this, now we can check. Remember when we ran the server earlier, we saw that when we do get slash, that's like the home page, right? So we can check to see if rec.url is slash. If it is, we can call this method fs.createReadStream, and that takes a file name as the first argument. So in this case, public index.html. And if we want to send that read stream, this is basically a stream is just a bunch of chunks of information over time. As the file is read from the operating system, we can call .pipe res, and that tells, so this stream of HTML is going to be basically pumped into our response object. And if the rec.url wasn't /, then we can just call res.end with like not found, because we don't know. And if you want to be extra fancy about it, you can set a status code. to be 404, for example. This is the file not found status code. The default is 200 for successful. Don't worry too much about status codes. You can read more about them on Wikipedia later if you want. Okay, so with this basic code, now instead of serving a static message that we type in our server.js file, if we run this program, we now see, cool, NF5 view source, we see the HTML, wow, cool, great, so that's from our file. But suppose that we want to put more files into our public, like an image, for example. So here I've got an image, cuddlepuff.svg, and I'll put that into our HTML. So after the h1, I'll do imgsrc cuddlepuff.svg. So now, if I rerun the server, we see, we don't see anything, right? Because if you go to cuddlepuff.svg, we get the message not found. This is because in our server program, we're not handling what happens when you go to /cuddlepuff.svg. So we could basically copy paste this whole chunk of text, and I'll do that for you right here. So cuddlepuff.svg, cuddlepuff.svg. So if I rerun the server now, it works. But this is not necessarily ideal, because every time you want to add a new file, you have to modify your server.js, and that's kind of a lot of work. So instead of making a lot of work for ourselves, we can get the computer to do a lot of work by using a module. So if you go ahead and do, we already did npm install --save ecstatic earlier, along with another module. And what the ecstatic package lets us do is it handles all of these pesky routes for static assets. So it's going to handle cuddlepuff.svg and index.html for us. How you use it is you require the ecstatic module like this. And now we can, so ecstatic, when you require it, is going to be a function. Then you call that function with the path name that you want to serve up. So in our case, that's going to be public. Right, so /public or just public is fine. Now we get back an st variable, and that st variable is also a function. And inside of our code, we can call, so we can basically delete all of this code that's handling our static assets and just do strec_res like that. Now the ecstatic module is going to look in our public directory, and it's going to serve up, if we request /, it's going to serve up index.html. Index.html is a special file name that means, well, serve up the root if path, or if we get a request for /cuddlepuff.svg, it'll serve up cuddlepuff.svg because those files both exist in our public directory. But if it doesn't see any of those files, it'll serve up a 404 message for us. So we reload, it still works. We can reload the main page, still works. If we go to something that doesn't exist, then we get a file not found message. So ecstatic is a nice way to not have to write so much custom code. But it's also good to know how that custom code works, because if you need something different than what ecstatic provides, you can go in and write it yourself if you need to. Okay, great. So this is the basics of how we can start to have some static routes.
So where are your routes being handled?
So right now, we don't, all that we have is we're letting ecstatic handle what should happen.
And it's just serving up all the files in public?
Yeah. Okay. So right now, all that's happening is
in the order it sees them?
No, there's no order, right? So console log rect.url, that's the request, right? That's a string, that's the file path. And so if I run the server now, reload the page, we see request to / into cuddlepuff.svg. So if one of those URL paths matches something that exists in the public directory, then it serves up the correct content by using internally something like fs.createReadStream.
Okay.
Yeah, question?
Why don't you use semicolons?
It doesn't matter. Not worth talking about that.
Okay.
So, anyways, so we have a program. You can use semicolons or not. It doesn't actually matter, and a lot of people get, it's like a pointless discussion because it doesn't matter. It's like, do you use 2 spaces or 4 spaces or tabs? Who cares? Anyways, so here we have a simple program. What if we want to do something more complicated? So what if we want to make a program that's going to be a sorting hat application for our School of Witchcraft and Wizardry? So what kinds of things are we going to need? Well, we'll probably want a home page, right? So we already have an index.html, so we can start to edit that, right? So here we go with the title. This will be a Cyber Wizard School of Witchcraft and Wizardry. And now in our body, we'll say Cyber Wizard School. Okay, so now we're going to maybe need a form for if we have a new student, we'll want to sort them into the appropriate house. We're not going to do that like in person. That's ridiculous. We can get a computer to do that for us because we have even more powerful kind of magic. So maybe we'll have a link to apply to be sorted. So we'll make a link for that, and we'll call it sorted, just /sorted for route. We can have a section that maybe we'll put these in a list. So what other sections would we need as a School of Witchcraft and Wizardry? Maybe we want a page to see what the houses are. So maybe we can have info on each house, like /house/ Cuddlepuff. We can have a house called Dragon Door, I think was the name. We can have a house. Hang on, I already made graphics for all of these, so yes. What? Well, anyways, we'll just put those 2 for now. Okay, so here we have some links now in our server. So if I run the server again, we'll see some links, apply to be sorted, and like some houses, whatever. So what we want to happen now is if I click apply to be sorted, I should go to like a different HTML page. So a simple thing we can do to make that work to start with would be to serve up some different content on that page. So what we can do is in our server, because that's /sorted isn't necessarily a static page, what we can do is we can check for if rec.url equals sorted or apply. We'll call it apply actually. So if that equals apply, we'll do something. Otherwise, we'll just let ecstatic take care of it. So res.n to do. We'll go into public. Change that link really quick. Okay, great. So now when we run the server, if we click apply now, we see this. Well, what? Oh, right. Sorry. Rec.url always starts with a /. So if we do that, then we go to this apply page, which just says to do. So a really useful abstraction to have as we build up routes like this is called a router. So it'll start to make sense if I put a few more of these things. So if I have a few else ifs in here, like /wizard / So maybe we want to have a page that like in a lot of websites how you have maybe like on Flickr you have /photos /username /whatever image. To build up routes like that is a little bit tricky with just ifs and else ifs, right? Because you have to sort of split apart the route and automatically figure out which parts you want to match for. So a nice way to sort of contain a lot of that complexity is to use a router. So what I like to do is in another file, we can set up some routing code. So if we make a new file called router.js, we can load the routes module by doing require routes. And how the router works is you call the routes module just like that. Or a more compact way to write the same thing would just be to go router equals require routes and then put a open paren, close paren at the end, because the routes package returns a function, right? And if we call it directly, then we get an instance of the router object. So there are a few things we can do with this router. We can call match, for instance. We can also call add route. The main thing we'll be doing in this file is add route. So if we call it router.addRoute, we can have a custom route for the slash page, for example.
And you put a parens after the route so that it calls itself?
Parens after the route?
Require routes.
This part.
Oh, yes.
This is, so the routes package returns a function.
Yeah.
And if you call that function, it will create a new router instance. But we only want to, we're only going to need a single router for our program. So we can just call routes this way. And it'll create an instance in the same line as it requires it.
As opposed to returning a constructor.
Well, the alternative, this is just a more compact way of writing something like this, where we would have two variables, but only one variable that we use once. So these two lines right here are the same as this line. Okay, so in our router, we can do a few things. If we pass the request and the response into our router from the outside, then we can handle them in a special way. So we could call res.end hello, or we could do for /apply application goes here. So now if we do module.exports equals router, then when I require this file from my other file, I'll get the router that we've set up and configured in this file. And for the module.exports, you can put that either right away, right after you create the route, or you can put it at the bottom, doesn't matter. Okay, so once we've created a router, we can actually start to use it. So from our server program, we can load our router by doing require./router.js. Now in the server, what we can do is instead of a bunch of if-else-ifs chained right after each other, we can call router.match on rec.url. And router.match returns a match object. So if there is a match, the match object will be some object with an fn property. But if there was not a match, then m will be set to null. So this else case will fire. So if there is a match, we can do something special with our route. Otherwise, we'll let ecstatic handle any static assets we have. So in particular, when we get a match object, I'll just print out what it looks like, and then we can play around with it. So if I run the server now again, and we go to localhost, we see that the match object equals this object. It has some things like params, and I'll show you more on this in a bit. So if you type in a question mark in the URL bar and do like abc equals 123, I don't think Chrome is actually reloading that. So anyways, we get certain parameters like params and route and whatever, but the big ones to look at are m.fn and m.params. So m.fn is that function that we declared in our router. So it's literally the same as whatever code we put here. That's that function. The router's job is sort of to, from an incoming route, match that rec.url to whatever routers we've set up here. So using this path, and there's a whole pattern syntax that we can use, it sort of dispatches to the appropriate file. So from our server.js, we can call m.fn, which is going to be the route function we've already decided is going to fire, and we can pass in the rec and the res, because that's what our router is expecting us to pass in. You can pass in whatever you want, though. You don't just have to pass in rec and res. You can pass in any kind of object. But once we do this and rerun the server, now we see a message, hello, which is what our router, or if we go to /apply, we see the message application goes here. So in our router code, we don't actually need the part that does hello because we already have an index.html that ecstatic will take care of, but we can handle some custom things like what our application page should look like. So once I reload this, there we go. And we're back on our main page. So now we've got a router ready to go to handle all of the different cases that we'll need. And we can start to make a form, perhaps. Okay, so one common thing you might want to do is if we have all of these different sections, like we have a home page, we have an application page, we maybe have some other page for like the wizard schools, and we'll want like a list of each student in each, sorted into each house. So we'll probably want like a basic HTML template to take care of the styling on each page, and then we'll want to somehow put in the custom content inside that HTML. So you could make a bunch of different HTML pages that have all of the content, but one problem with that approach would be that you'd basically be copying the template file into a bunch of different places, and if you want to make changes to any of those files, you have to change every single file. And that's kind of this sort of menial drudgery that we can eliminate by using programming. So there's a great quote. Marina, do you remember the quote?
The
Tools?
Unix rule?
Yeah.
As we learned in the first talk about Unix, one of the sort of like guiding principles is build tools instead of using unskilled help. And like you are the unskilled help if you're retyping HTML. So it's like it's worth it to take the time ahead of time to make a tool that makes it so you don't have to repeat the same menial task, because that's computer work.
Yep.
And because it's worth it in the long run.
Yeah, okay, so here we have some HTML, and if we want to make it so that maybe this is our header section, right, with our links, like apply and whatever, maybe a link back to the home page. And then we can set up a div after our list of links that we can use for arbitrary content. So it's common to give that div an ID like content or an ID of body or something like that, because that's where we're going to stuff all of our custom HTML with some libraries. So once you have some layout HTML like this, we can change our code a little bit. So now instead of maybe passing in rec and res, we can pass in some different parameters. So remember that M has a params function. So if we pass in the match object directly, we can do some neat things. And if we have our M function return some HTML, we can use that. So if we change our match functions in our router, let's do that first.
So sorry, there you were calling the function on M and passing M as a parameter to that function?
Yeah.
Okay.
So m.fn is just a function, right? That's the function that we declared. And I'm passing m in because it has that params value that we might want to use for some things. So now if we change our routes around, instead of doing rec and res in here, get the m object inside. And now instead of calling res.end, we could just return some HTML. So we can return like b apply now. Or maybe like a blink tag if those worked, RIP. No more blink tags though. So just b tags will work for now, right? So maybe in our routes we can return HTML. So if we modify our server code now, okay, so what we'll want to do now is take our basic HTML template, and which is index.html, and we'll want to stuff in whatever content we get from our routes. So we have that HTML in a string. How can we put it into our HTML document? So there are a lot of different ways to do this kind of thing. One way that I like to do is use this module, which I wrote, called hyperstream. So disclaimer, I wrote it, so of course I would like that kind of thing. But to wire to wire that up, I mean, there's a lot of different approaches, and they're all pretty good, but we can now create a read stream like before from public index.html, and we can pipe that stream of HTML into the hyperstream module like this, and hyperstream takes an object as its argument, and that object maps CSS selectors to snippets of HTML that we might want to insert. So remember from our public index.html file, we've got this div ID equals content. So the query selector to match the content div ID is a hash and then content. So that'll be our key. And then the value will be the snippet of HTML that we just got back from our router functions, in.fm. So if we do all of this, hyperstream is going to return another stream, and we can pipe that into the response. So hyperstream takes in HTML, it looks for certain patterns that we want to match and manipulate, and then on the output side, it's the original HTML plus our modifications that we've inserted. So it's a sort of pass-through transformation, just like sed or grep, where you're taking some input, changing it, and sending it back into the output side, is what we're doing here. Okay, so once we've done that, then I think we can just run this. So here we go. We run our server. We go to the main page. It's just, let's see. Right, the main page right now is not handled by a route, but if we go to apply, then we see the message apply now with bold text. So fantastic, it's all working properly. What's nice about this now is we can make as many pages as we want really quickly, just by modifying our router. So if I want to add a new page that has some different HTML, I can just do slash whatever, and I can say like whatever, and rerun the server. Now if I go to slash whatever, I see whatever, and if I go to slash apply, I see that message. So we can very quickly, instead of copying an HTML file and editing it, we can just add more stuff. So this is the basics of how routers work, but there's a few other fancy things we can do that it's worth showing. So one really nice property about routers is that they have this pattern matching syntax inside of them. So if we go, maybe we're going to want a page that's like a house and then whatever name of the house. So there's going to be 4 houses, but we're not sure what they're called yet. So we can use a colon, and then a colon is like a special character that says whatever string comes next is going to be a variable. And now inside of our function here, m.params is going to contain a value for that variable. So we can access m.params.name because we called it name right here. So if now instead we return maybe an underline tag plus the m.params.name, we'll be able to go to a custom thing. So if I go to /house/dragondoor, I'll see with underline text the string dragondoor. If I go to any other house, I'll see a similar thing. So we start a server, we go to house dragondoor, we see the text dragondoor. We go to some made-up name, we see the made-up name. Cuddlepuff, there we go, Cuddlepuff. Fun. So this is a way that we can sort of have those fancy routes that you're maybe used to on SoundCloud or Flickr or whatever, where you see different pieces in the URL. Okay, so that's the basics of a router. Now, it's a little bit cumbersome to generate this HTML with strings, so there are a lot of different approaches for doing this part, but one module I like to use is called Virtual DOM. It uses this syntax called hyperscript, which is just a way to make HTML with JavaScript functions. It's not to everyone's taste, and there are a lot of different ways of doing this part, but I'll just show you the way that I like to do this kind of stuff. So, one problem is you could put HTML inside of the HTML, and this is an XSS attack. Whoops. Well, I would have to do this with Perl, but you can put HTML codes in the URL bar and then Unfortunately, you could have a script tag, and maybe if you're using document cookies, you could compromise some of the session if you had a user system. So it's not a great idea to allow arbitrary input into your HTML. But if we use some modules for doing this, like we can require virtual dom/h, we get this h function. The h function takes in the tag name. So I'll go ahead and replace all of these with what it would look like in HyperScript. So instead of putting those b tags in directly, we now call the h function with the tag name and then the text that's going to go inside it. Likewise for our I tag, and likewise for our u tag. So that's what it looks like with HyperScript. And restart it. We see, right, but HyperScript actually returns a special kind of object called a virtual DOM. So if I require virtual DOM h and try to make a b tag, I get this object. We have to call another function in our server code now to convert that back into a string. So it's a little bit roundabout, but with some of the other libraries I'll be showing later, it'll hopefully make more sense why I'm doing it this way. So in our server code, we can call this function create element from virtual DOM. And now when we get back our HTML node, we actually need to call create element on that first. Does that make sense? So here I'm just calling an extra function around it, and I can call toString to convert it to a string. So once I've done those things, now it works just like before. So one cool thing about about making routes this way is that all of this code will also work completely natively in the browser. So if we wanted to make a web page that had elements that ran in the browser and ran in the server, or maybe we start rendering in the server and then we upgrade into rendering things in the browser and doing things like client-side routing, we can reuse all of this code because all of this code works perfectly fine in the browser too. Okay, so maybe the next thing we should do is build the form for submitting our application to our House of Witchcraft and Wizardry, and we can do a kind of sorting algorithm, quote unquote, for that. So, so we can make a little form here. Like here we can have a form. To make nested elements, you can pass an array to HyperScript like that, and now you can do things like input, type, text. So this is a little bit different than maybe you're used to with HTML, but type submit. Yeah, but it works pretty much the same. So we're going to have type text, and name is name. Maybe we'll put a div around that. So we can say name. So we'll have a name in our form. We can have favorite animal. I don't know. We can do a lot of things. But maybe we'll just have a name to start with, and we can build out stuff from there. And our form value will now say apply. So if we rerun our server now and get home, click apply. Now we see name, apply. Cool. So one thing we haven't done yet is put those method and action properties into our form tag. So we'll want to do a post, because if you do a get, it just shows up in the address bar and it looks kind of crappy, and it's also less secure because it's available in the browser history. So we can set our method to post to get around that problem, and our action is the URL that we want to apply to. So our action can just be /apply, just like our route here for doing our get part. But in our server code now, you know, this router is going to handle routing stuff, but we can do another thing. So if rec.url is apply, and direct.method is post, we can have our custom thing. Else, if there's some other stuff that happens, we can do that. So now in here, we can use another package to decode the form parameters that we get. So, but first, it's kind of nice to just see how the forms work. So we did this a little bit in the networking lecture, where we used Netcat to spin up a fake HTTP server, and then I just typed in the responses manually. You get a kind of similar interface with the rec object. Rec is a readable stream, and we can pipe that to standard out, which is process.std out, just to look at it to see what it looks like. That's a kind of fun exercise. Okay, so now if I restart the server, I reload this page, we can type a name, Harry Potter, click apply. The page isn't going to load, but on the command line now we see this message, name equals Harry Potter, Harry plus Potter. This is a special kind of encoding called URL encoded. If we have a string like this, how you can convert these messages into something a little more sensible is you require the query string module, which is built into Node. It has a method called parse, and if you paste in one of those strings, you get back a nicer object that directly tells you. So if you ever see a URL with like a %22 or something like that, that's one of these URL encoded strings, and there's a special algorithm that just turns them back into something more sensible. It's just a key value kind of object. So we could do all of this ourselves. I can show you how to do that with concat_stream really quick, but it's not very nice to do. It's especially hard to do it properly. You can use another module like concat_stream. All the concat_stream does is it takes a string as input, and it just gives you a variable that just contains all of the contents. So it's like if you have an fs.createReadStream, you type into concat_stream, it's just the same as doing fs.readFile, which just gives you a big buffer of all of the content. So we could do something like rec.pipe concat, and that takes a callback that just gives us the body, so we could look at that. Then we could do, if we loaded query string, we could query string.parse that body, which is a buffer, so we call it toString on it, to get params. We could do all of that in console.log the params. And I'll just, oops. So here, that worked. We get the variable, but it's a little bit hard to remember all of those pieces, right? You have to remember to pipe in direct.body and call out these weird functions and things. So what I like to do is there's this module called body on npm. So if we npm install -- save body, we can read the readme. Oops, I guess I hadn't installed it. So I'll actually install it. And then you can load this body/anything, and all that does is it does URL encoding and also JSON encoding. So with APIs, it's a little bit more common to send body form data as JSON instead of URL encoded because it's a little bit nicer to deal with. But this body module will handle all of those different cases, and it's going to do all of this this stuff with query strings and whatever, so we don't have to worry about that. So if instead of all of this code, we now call body, you give it a rec and a res. Here's an example. So you give it a request and a response object, and then a function, and the function has an error as the first argument if there was one, and the second argument is the params object. So now if I print out the params object, we should get the same kind of behavior that we got before from our form. Yeah, so it works the same as before, but it's less typing, less to remember, less to get wrong. Also, the body module is going to truncate requests, I think, at about 1 kilobyte, because if we just used concat_stream like I showed before, an attacker could use up all of your RAM on your system, because that concat_stream is going to keep concatenating until you run out of memory if someone sends you a really, really big payload. So there are nice things that these modules do for us that we don't have to do ourselves. Okay, anyways, if we have these parameters, we have to actually save them somewhere. So we'll need some kind of persistence layer. We'll need some kind of database. So how can we do that? Well, what I like to do for small projects like this especially is this really lightweight database called LevelDB. So with LevelDB, you just npm install --save level. It's going to compile some things with C, so make sure that you have a C compiler installed. And it does take a little while. But once you have it installed, you can just var level equals require level, like that, which just loads the package. And then you can create a handle on a LevelDB instance just by giving LevelDB database file path. So if we do like /foo.db, now LevelDB went and made this foo.db directory, and it has all of this like databasey things in it. We pretty much never have to look at what those files actually contain, but that's where the data lives. So just like how node modules is local to your project, with LevelDB you can also make your database completely local to your project and completely isolated from everything else in your system. So it's a really small amount of setup. That's why I kind of like it for stuff. It's especially good if you want to ship a command line tool on NPM, because you just tell people to npm install your package and they don't even know that you're using LevelDB behind the scenes. They don't have to configure anything. Anyways, with LevelDB we get a few fun operations like put. So put is used, so LevelDB you can think of it like a big object that lives on disk. So it has keys and values. With put we can set a value in the database. So we call put with a string. Like
so does that make it like a relational database?
No, it's a key value store. But it has some features that let you build more advanced kinds of storage things. Anyways, but the simplest way to use it is just to call put, like our key name will be wow, and our value will be cool beans, and we can give it a callback if we want. That'll just, if there's an error, we'll know about it. So if we do that, we didn't get an error, so that means it was successful. And later, we can kill our process, we can go away, but later, if we load level again, level, there, db, level, foo.db, if we do db.get on that wow value, there's our value. So we killed our program, but our value persists. That's the big thing that databases give you. So if you just stored that stuff in memory, then if your program crashed and you restarted it, you would lose everything. But with a database, you don't have that problem. And you can save things for later. So we'll just use put and get for now, and I'll show you some more methods later as we need them. But the basics, put and get, pretty simple stuff. Okay, so I'll just delete that test database for now. Okay, so how can we use LevelDB in our server, right? Well, one thing we can do is if we have our students apply, then we want to save that somehow. So first of all, I'll load LevelDB, and I'll make a database handle, level students.db. And now in our form, I can call db.put, params.name. Maybe I'll include, so this is our key, right? So maybe I'll actually want to include something before we do our params.name. Does that make sense at all? So I can include a prefix. This is some text that's going to sort of identify in the key what kind of key it is. It's common just by convention to use a delimiter, because then you can have more kinds of keys. So if you want a key that's called like student something, you can also have that key if you use a delimiter. It's kind of common to use an exclamation mark as a delimiter because it has a low ASCII value, which you don't have to care too much about that, but exclamation mark works pretty well. So if our key is student, exclamation mark, and then the student name, our value can be whatever value we want to compute. And so we can put our key and our value into the database. Now if there was an error, we can just res.end error. Otherwise we can say res.end okay. So what kind of value do we want to store? Well, we can deal with that later, and we can implement a sorting hash, kind of sorting hat algorithm for this. But for now, we can just have an empty object. If you want to store JSON in LevelDB, the one thing that you have to do is when you call level up here, you have to do value encoding JSON, just a small thing to keep in mind. Otherwise, you can only store strings. Okay, so now, once we've done all of this, when a student applies, oops, I rerun the server and I reload the form. Harry Potter, quick apply. Okay, that means it succeeded. But how are we going to read back these values? Maybe we want a list of students, right? So the next thing we can do is start to build that. So we can use these other layers that we've built to build that part. Any questions so far? I've covered a lot of ground, and I'm going to cover more, but hopefully...
No, this is cool. Are we going to see the completed code for it?
Yeah, I'm going to post all of the code once this is done.
James.
Yeah.
So you said one thing previously. You said that you could call toString on body because it's a buffer. Could you explain that? What is a buffer?
So buffers are built-in node types. You get buffers back from certain API calls like fs.read file, or if you have a stream, you usually get buffer chunks back. Whenever you have a buffer, so like here's a buffer, var buff equals that. It's binary data basically. And if you want to convert it to a string, just call toString. That's all.
Okay, cool. And one other thing, you said that there would be a way that you could flood the server's RAM.
Yes.
How would you do that? Could you just say that one more time?
So it's common if you're building node servers to accidentally have things called memory leaks. Memory leaks are where the server is slowly allocating more and more memory over time and not releasing it. So if we took the request body and just piped it into concat stream, then someone could send us like a 10 gigabyte form body, right? They could send a post message and they could just keep sending us data, and our server would just keep buffering all of that data into memory. And then we, on our cheapo DigitalOcean slice, would run out of memory and our server would crash.
Right. So how do you prevent against that?
So you can either statically, so once you've read out a certain chunk of memory, like 1 kilobyte, you could say, oh, that's too much memory, and just kill the connection.
Okay.
And that's what the body module does for us automatically. So we don't have to write that code ourselves.
Thanks.
Okay, great. So the next thing we can do to start fleshing more out of our Witchcraft and Wizardry School web app is we can read out our student list. So we already have at least one record in our database. Why don't I make another one really quick? Apply to be sorted. Ron or Hermione. I don't know how to spell that word. Hermione Granger. Apply. Okay, so now we have at least two records in our database, which is fun. So what if we have another route that has a student list? So what we can do is maybe we want to keep the same rendering on our page. So inside of this else if block, we can pass in another parameter, m.fn, specifically for our student list. So if this was a bigger app, I would probably just create 2 separate routers, but for the simple stuff, this is fine. So if the URL is students, we can keep a state variable around just as a kind of grab bag where we can put different pieces of state. And inside of our m function, or inside of our m object, we can just save a reference to that. So actually, that works just as well. Anyways, that's just going to be where we're going to put these values so that our routes can see them. So if our rec.url is students, what we can do is we can do db. This thing, create read stream. I'll explain how this works a bit more in a moment, but basically create read stream takes ranges of keys. Why don't I just show that on the command line? That'll make much more sense. So if we have a LevelDB database, You can learn much more about this stuff in the Node School workshop called Level Me Up. It's really fun. I recommend it. So if we have like a temp, whatever, .db, now we put some things in our database like AA, 3. And dog. Okay, so now if we do db.create read stream, and this is going to return a stream. So a simple way to just print out whatever's in a stream is to call console log whenever this data event fires. So if I do that, I'll get these rows, key, AAA, bananas, and dogs. So that's everything we put into the database so far. If we want to get a subset of those values, we can pass in certain properties into create read stream, like greater than. So what if we want to get all of the keys that are greater than B? So now we get bananas and dog, but we don't get AAA. If we want to get greater than C, we'll only get dog back. So we only got dog back. Does that make sense for everyone? There's also a less than key. So less than B only gives us AAA back, and you can use less than and greater than at the same time. So greater than, let's see, less than C, greater than A, only gives us, gives us A and B. But if we did greater than B, we would only get the B key. So you could basically specify greater than and less than for these strings, and it does a string kind of inequality. So we're going to be using that to pick off just the list of students, because remember we put that prefix in front of our keys, so students, exclamation mark. So if we pick off everything from students, greater than students, and less than students with some sort of high ASCII value, so like students FF or tilde is kind of common because that's the last ASCII character. So every ASCII character before a tilde will match. Anyways, if we do this, it will give us a list of the students. So back to our code. Greater than students, less than students, tilde. Then that stream is going to give us back a list of all of our students that have applied to our form. So now what we can do is we can buffer up all of those students into a list maybe. I mean, you could also do this in a streaming fashion, but for now we'll just make a list. So more info on this in the stream adventure and the stream handbook, but I'm going to be using a package called through. Just to get all of the elements. So through. Actually, now that I remember it, there's a package called collectstream that does exactly what I would have written with through, so I'll just require collectstream, like so, and npm install --save, or -S, even shorter, even less typing with your meat fingers. So collect-stream, and that's going to update our package JSON for us with that dependency. So now, if we pipe into, we don't pipe into it, we call collect on our function, and we get back all of the results from the database. So now we can update m.state with those students. So m.state.students equals rows. Okay, the last thing is this callback is going to fire after all of this has happened. So we need to move all of this code into its own function. So I'll just make a function around that. I'll call it a render, maybe. And the render function can take the m property as a variable. So I think that should work. So if.rect.url is students, we'll call render in here. Otherwise, we'll call render right away. So does that make sense at all to everyone? Any questions? It's kind of a lot of moving parts, but you'll be able to pick apart this code later when I post it on workshop repo. So we're using our database to fetch a list of our students, and we're putting that m.state.students into our database. So the last thing we need to do is update our router so that we have a students route, right? So /students. Now m.state.students is going to be set, and that's going to be all of the rows from our database, so all of the values. We can take those, and the key is going to contain the name that was submitted. So now if we return a div, and inside of our div, we can just have a list of all of our students. So if we use a map on that students array, then each student S can be another div. It's like div with a class name student, and we'll just put the m.key into the text, which is going to contain the students exclamation mark part, but we can pretty that up later. So this is just to make sure that everything is wired up correctly. Okay. So all of that aside, now if I run server.js, which I guess is still running somewhere. Oh, there it is. So if I run server.js now, it's running. Okay, so if I go to the main page, it still works. If I go to students, then it didn't crash. Let me just print out what the M is. Okay, so the state of students is actually empty for some reason. But if I go back into the server code, let's see if we can spot the error. If rect.url is students, create read stream, collect all of the rows. Oh, I see what it is. When we stored our record, we didn't put an S with our student. So the keys are actually student, not students. See? So you have to get everything exactly correct in computing whenever you do stuff like this. And still empty. So let's just make sure that we got everything. Greater than that, less than that, okay. So we should have some rows, but we don't see them. And the HTML is empty. Oh wait, the HTML is not actually empty. There are students in there the whole time. The reason is, I think, that I returned an object. So in the rendering code for students, oh, I did m.key. I meant to put s.key, which is the string. M.key is undefined, so that's why it didn't show up as anything. Restart our server. There, we get some records. So here is a list of our students. We have this annoying prefix, but aside from that, it works, which is great. So let's remove that ugly prefix now. We can call .split on that exclamation mark, and just only show the second element. So when we test that out, if we copy one of these strings, we call .split on that with an exclamation mark, we get an array, and we only care about the second value, which is index 1. So that's what we're doing here. And restart the server, and there is a list of our students. Great. So we have a list of our students now. Why don't we add another route for each student, so each student can have their own page. And we can show what house they've been sorted into, and we can maybe, when they submitted their thing, they could type a silly message that's with them forever, because we don't allow them to update their own pages. Okay. So, what do we do now? So, the first thing we can do is, for each student, we can make a link from the student list to another page. So, we can add a new stub route first. So, maybe we have a student/name. This is going to be the student page. So, return H, student page goes here. Student page 4, actually, because we have the m.params.name available, so we can print out what it's going to be the page for at least, because of that colon name in the route. Anyways, now we'll want to link to that route from our other route. So here in the student page, this is the student name, so why don't we go ahead and save that to a variable because it's kind of ugly to look at, so name equals that. Now div.student is going to live in an A tag with the ref of student / plus name, and the text can be the name as well. Okay, so hopefully that makes sense. We're just adding some links now to our page, so if we refresh, we see some links. We can click them. Click on Hermione Granger. Student page for Hermione Granger goes here. Forgot a space, but aside from that, it's pretty good. There's our space. Okay, so now that we have our list of students, we'll want to also do some database records. So from our server code, the next thing we'll probably want to do is pull up info on our student. Unfortunately, we weren't saving any data to our database when we created the students, but there's a few things we can do using only the name. Like, let's take this opportunity to implement the sorting hat or the sorting hash. So if you remember from modulo arithmetic, so in Harry Potter there's 4 houses, right? We're gonna make silly names for them. I've already made some images. There's 4 houses, right? So how can we take a name, any name, and map that to 4 houses so that it sort of is an even distribution? There's a neat trick you can do. If you have a buffer, right, of any text, there's this method that's built into Node called .toString, and you can give that the string hex, and then it gives you hex, the hexadecimal string for that name. A fun little trick you can do is if you take the last, or if you take either the first character or the last character, or any arbitrary character. So we'll take the first character, 6. If we can convert that to a number, so 6, and if we do modulo 4, so hex characters are going to have 16 values. Actually, I'll have to use parsing because those might be, right. So parsing, how it works, I'm kind of getting all over the place here a little bit, but parsing can take a value in hex, and if you give it the second argument of 16, it's going to interpret that as hexadecimal. You have like FF or whatever. So if we have 1 character of hex, there are 16 possible values. So if we have our function here that takes 16 possible values and does modulo 4 on that, we'll get 4 values, which can map uniformly to 4 houses. So var house index equals, and then like inside of here is we can put any kind of string that's going to be unique, like someone's name, and know what house they belong to. So this can be the basis of our sorting hash function.
So does that string have any significance, or could you just put the letter A?
Could I just put the letter A? The string? No, it doesn't have any significance really. We're only looking at the first character though, so all of the H's will get sorted with all the other H's, which is maybe not the best. So a better thing we could do actually is to use a cryptographic function, but I'll add that later. For now, this is fine. So if we copy paste this wacky code that I just made up into our server, so actually I'll make a separate file to put this code because it sort of does one thing. It can live in one place so that we don't have to copy it all over the place. I'll call it lib sort hash.js. It doesn't use a hash yet, but it will. So we'll do module.exports equals function. Our function is going to take a name as its argument, and it will return which house. So it'll return houses of house index, and we need to make up some house names now. Okay, so var houses equals, I came up with some of these earlier, like Dragondor, I think was one of them. The other one was Cuddlepuff. That's our cuttlefish that we already saw. And I should copy these as well. So CP media vector Cuddlepuff. I think I already copied that. Another one is dragon door. Let me just open Inkscape really fast because that had all the file names in it. So it takes a while to load. There it goes. Open recent dragon door. Where did I save this? Oh, I just saved it in my home directory. That was stupid of me. Okay. Yeah, and I saved Kitten Claw as well. That was the other one. Public. And Serpent Snake. Okay. Great, so now we've got those names. Fun little thing you can do in Vim, R exclamation mark to run a command. So if we want to see all of the SVG files in our public directory, there we go.
Wow.
I can block select and then cut off the .svg. Great, so now we've
How'd
got
you
a
do
list.
that? Cut off the .svg?
Just a little regex.
Wow.
Oh, we can do another regex to add quotes. So replace the first part with a quote and the last part with a quote comma. There we go, we've got a list. Great, so there's our list.
Cool.
And if we run this function now, we can start to play around with it on the command line. So node require lib sort hash.js. Good. Wow. Okay, Serpent Snake, Draco, Kitten Claw, Harry Potter is in Cuddlepuff. Unfortunately, any H is going to be in the same house because of how we've written it. So let's write it a slightly better way. Let's use a hashing function. So how hashes work are, if you have some string, there's a program on the command line called SHA-SUM that uses the SHA hashing algorithm. So if we pipe in a piece of data to SHA-SUM, it's going to give us this string of output. So it starts with 0, 3, right? If we change it at all, it's going to give us a completely different string. So this one starts with 3, and that one starts with 7. So even if you make very small changes to a hashing function, a good hashing function will give you really different outputs so that you can't, so this gives us a really nice uniform distribution that we can use for our sorting hash to sort people into houses. So what we can do is there's a module called crypto in Node that we can use, and it has a hash function. So if we do C equals crypto.create hash SHA-256, actually let's call it H. Now instead of calling buffer of name, we can call buffer on hash. So if we do var hash equals h dot update name dot digest hex, that's going to be the same as doing toString of all of that stuff before. So there we go. Yeah. So done all of this. If it works, then if we pass in, even if we pass in names that both start with H, we should get different houses. At least most of the time. So I'll just require that package again. So if we sort Harry Potter, we get Serpent Snake. If we sort Harry Patter, we get Kitten Claw. So it's working. Hooray! So we can use this sorting hash function now to put that on our student pages. Why not? Great. So, oh yeah, and you should be using Git. I haven't been using Git, but let's do that, right? That's good practice. And Git add with whatever. Basic routing DB and the sorting hash. Great. So, what we can do next is in our server.js, we can actually, in our router, on the student page, we can put the house that a student belongs to. So let's think. Maybe we want an h1 tag for the student name. So end.params.name. That'll be at the top of our page, and then we can have a div that says like a student of house and then we can do the sort hash. So we'll get that from a variable called house, and we can compute that based on our sorting hash for m.params.name. So if I load that sort hash function from live_sorthash.js, if I reload 30, right. If I don't have syntax errors and I reload, then if I go to Hermione Granger, a student of House Serpent Snake, fantastic. So we've got our original content from our index.html to now our div. We have a basic student page. It's all working, fantastic. If we go back to our student list, click on Harry Potter, a student also of House Serpent Snake. That's just coincidence. Let's add another student, maybe, what's a good wizard name?
Merlin?
Which?
Merlin.
Merlin. Okay, apply. Okay, so back to our student list. If I click Merlin, a student of House Serpent Snake. So obviously I'm doing something wrong, I think, because that's statistically unlikely. I'll just double check this. Dumbledore. I don't know. So if we go back to our student list. Okay, so actually that was just pure coincidence. I think it's working. There are only 4 outcomes, so it's, yeah. Anyways, so all of this appears to be working now. One thing that we could do also is if we want to have house pages, how can we generate lists of house pages that only include the students in a particular house? To do that, I think what we can do is delete all of our existing content because we need to store some extra things in the database. I mean, there are ways of doing it with our existing data, but it's just easier to delete everything and do it again. So from our student list, in our server, when we create a student, right, we set this key value with db.put. What if we want to right there compute what house they belong to, and we can put them in some different, we can also update some other keys. So if we want to do something like a db.put right after another db.put, there's an even better way of doing this. It's called db.batch. And with db.batch, you can atomically do multiple inserts and deletes at the same time, and they'll either all fail or all succeed. So this is nice for keeping your data consistent.
By
Anyway.
atomically, you mean one operation won't complete if another one doesn't?
So atomically here means that either all of them will succeed or all of them will fail.
Okay.
So it's like that's the atomic part.
Okay.
Yeah, they're all sort of like, you won't get one that succeeds but another fails. If one succeeds, if one fails, everybody fails. Okay, so anyways, if there's an error, we'll just copy that logic from before. But in our db.batch, you have to pass in objects. So we'll put our student here. But one nice thing is maybe we can include the house directly in the objects we're storing in the database. So var house equals sort hash params.name. So we've got to load our sort hash function like so. Okay, and then the second record we want to put is also a put, and the key will be house plus that whatever house it is, and then plus whatever student it is. And the reason for doing it this way is that when we want to query this data, when we want to create a read stream, what we can do is set our greater than to be whatever house that is. So we would do like greater than house exclamation mark kitten claw, and then we can get all of the students that are part of that house. So this is just a simple way to do that. We don't really need a value, so any arbitrary stub value will do. So here we go. We've got 2 records now, the house and the user. So if now I'm going to delete the database and just like start over. Oops. syntax error, line 24. Right, there we go. Okay, so apply to be sorted, Harry Potter. Okay, make some more. Draco mouth oil.
Atticus.
K.
Yeah.
Of course with a K. Chaoticus. Okay, great. So now, we'll need to make the house pages with lists of people in each house. So to do that, in our server now, we have these records for each house, right? So now, if rec.url is students, that's one thing. Otherwise, if rec.url we'll split on slash and check if the middle one is equal to house. And then we'll do just a lookup for that house and then forward the state along to our other rendering. So what we can do is db.createReadStream on the house name. So the house name is going to be like this. And the house part of the URL, it's getting a little messy, but it's not too bad. This is where a router would really help us out, but creating a second router would take a little bit of time, so I won't do that right now. We will use the router in the client side though, in just a bit, because that's a fun thing to do. So anyways, we have our route. We can do a collection like before, where we get the rows, and we can set the state.students just like before to the rows. But this time the students are only going to be the students in a particular house. So in our router now, for each house, we'll have m.state.students. So we can have a div maybe, and then we'll have an h1 tag that's like house plus the name of the house. And then we can have a list of students. So m.state.students.map function s return h div of let's see, s.key, which will be ugly like before, but we can clean it up. Okay, cool. So I restart the server. If we go to /house cuddlepuff, Draco mouth oil. So that appears to be working. It's not the prettiest thing. Let's clean up this a little bit by getting rid of the first part of the key. So var name equals s.key.split, and we want the second element. There we go. It would also be good to have a list of all of the houses. So the fun thing we could do there is the only place we have that data right now is in sorthash.js. So what if we take that data, we write it out to a houses.json file, and then we just load it from a JSON file. That way our house data will be in one place and we don't have to copy it all over the place. So houses.json. In houses.json, now we've got to make it valid JSON, so we can do that by replacing single quotes with double quotes, and we're good to go. Some little regex trickery there. Git add houses.json and restart our server. Now in the home page, or in the title list, it would be really good to have that content. So from our server code, we can do something like that. Actually, why don't we add a houses page that just lists our houses out like we list our students out. So we can add route houses. And in here, I'll just require the houses file directly because it's a very small amount of data. So load that from the JSON file, and we'll just return hdiv with houses.map. And then each house will get its own div, like that. Great. So if we reload our server, go to /houses. Do we fix a syntax error? Is this common? There we go. And oh right, we can't use the h function because that's already defined. We'll blow everything up. Okay. There we go, house list. Great. So those are our house names. Let's turn those into links really fast. So we can just click them. In our router file, those are going to be divs. So we'll just add a ref is house plus name. And the text is just going to be the name of the house. There we go, clickable. Let's see who's in Dragon Door. Nobody. Who's in Kitten Claw? Chaoticus is in Kitten Claw. And Serpent Snake is, that's what Harry Potter is. So, fantastic. So, we have our not that pretty, but functional web app. It does some things we're rendering on the server. So how can we do some of the same rendering on the client? How can we start to build more advanced functionality on the client side? So one thing we can start to do is I like to make a browser directory to kind of keep the browser-only code separate from the rest of it. So what's a good thing that would be appropriate for the browser? What if we have an application process where you have to actually draw a shape of like an animal, and it's like tea leaves style, and then it morphs into the house image? That would be really fun. Why not? Let's just make that. I know how to do that. Okay. So first of all, on our houses page, we should have an image for each house. That's easy to add. So in this is still server side, but in our router, we can put in an image for our house. So an img src with just the m.params.name plus .svg. I think that should work. Right. Close brace. There we are. Cuddlepuff. It's a cuttlefish. It could be a little smaller. There's a kitten for Kitten Claw. There it is. It's pretty cool. Okay, so how can we do some browser side stuff? Well, in our browser directory, we can have a main.js, and we can start to load some different packages. So, well, I can't really think of something that would be super appropriate, actually. I guess that application process. Yeah, that would be a little bit tricky. Why don't we actually take a break, and then I'll think of something better that we can add for our browser code, because we've kind of covered a lot of ground already. So I'll put this code on GitHub right away, and then we can maybe resume in just a bit with some front end, some more of the front end side of things. Questions?
Maybe add some scripts for the startup.
Oh yeah, that's a good point. I was going to do that when I add the front end stuff, I think, because it doesn't make too much sense just yet. Okay. Yeah, we can start a new stream for the second half.